I think we're good. I think we're recording, yes.
Yeah, good morning, Amnon. Good morning, David. And very good evening to all the participants. I welcome you all to this second day workshop on NLP++. Looking forward for a great learning today also. Thank you. David, you can, over to you, David. One sec. You can unmute yourself, David. No? Yeah, now you try.
Okay, there we can. Okay. All right. Let me go ahead and share my screen. Let's get started here. Screen 2.
I'm sorry. You can unmute yourself again, David.
Okay, can you hear me now?
Yes.
Okay, great. I'm gonna, I think I can stop my video. Don't even know how to do that from here. So I'm gonna stop sharing, stop my video so we don't have that interfering, and share again. Okay, I think you can hear me. Yes, today is our second day in the workshop. It's going to be really a lot of fun. I'm really looking forward to this. Again, I'm David Hilster. I've been 7 years with the supercomputing group at LexisNexis, and we have a relationship with RVCE. Been gone many, many years, very fruitful and productive. I have 35 years of practical experience, currently working on an NLP++ plugin and bundle for HPC systems, and also real applications in our company and outside our company with companies that use HPCC. And I am co-author of the computer language NLP++ and creator of VisualText, Amnon Meyers. The other person, we two are the architects of this system. He's the CTO of Conceptual Systems. Also 35 years of practical experience in NLP experience. Practical NLP, and he is currently working on NLP++, VisualText, and open source project. He's also the co-author of the computer language NLP++ and creator of the conceptual grammar, which we talked about. If you didn't get a chance to see yesterday's, it would be really great for you to take a look at that. Our first day, we did a brief history of NLP and NLP++, how NLP++ fits into the world, why it's become very popular right now, and the NLP++ language. Amnon talked about that, and of course, the conceptual grammar. Today is going to be a really fun day. We're going to walk through analyzers, real analyzers live with you, and Amnon's going to talk about real-world examples of NLP++ working in industry. The analyzer walkthroughs, I'm going to go, actually, I'm going to build, this is just kind of an idea, but I'm going to go from building an analyzer on the fly, right with, from scratch, all the way to a full English parser that took 20 years. So building it from nothing to a parser that actually took 20 years. And the good thing to know about is when you build analyzers with NLP++, you can constantly make them bigger, better, bigger too, but better. As Amnon says, you can think of them as pancakes, and if you've got your stack of pancakes that's doing what you want, and it's not doing exactly what you want, you may have to go up, put another layer into that, and work on it. So it's very flexible. So what I'm going to do is I'm going to get out of this here and bring up the analyzer, VisualText, VS Code. And what you have here is VS Code. Let's take a look at how you can get the VS Code. So you load VS Code. Let me view this and zoom in one. There you go. I think that's going to be better. So NLP, if you just type in NLP, you're going to see these different things you can install. The other NLP things that you see, extensions here, are not related in any way. We just got this out a couple years ago. It's almost 2,000 downloads already, but this is what you want to download. Once you download that, you're going to see this over here. You're going to also see visual text at the bottom, but I like to drag all the things in visual text over to here. And what you'll see over here is an output files, analyzer, logging, and then the find results. Well, we have a special find for this. Again, all of this would be normally under visual text here, and that's how you would do it. Now, if you want to learn more about it, we have some really handy dandy video links right there. You can see these video links. So help video on the analyzer sequence, help video on the KB viewer. And this one's really good, which is a help video on VisualText version 2. So if you click on this, it'll go directly to YouTube and you'll be able to see all about this new version 2. So we're going to keep it this way because I like to keep it vertical. This is my preference. Of course, you can do it any way you want. And we're going to start out today by building an analyzer from scratch. So what we're going to do is when you make a new analyzer, you're just going to get tokenized. That's always comes with it. You can change what kind of tokenizer. And then you can put up your text up here. Now, what I have up here are a bunch of resumes. These are open kind of source resumes. These are approved for anybody to see. And what I want to do is just a corpus study. I want to see what kinds of words are in all of these files. So I want to build an analyzer that'll run through and just do some, word counts and stuff. So the first thing I'm going to do is I'm going to go get a library class called KB functions. Those are functions for the knowledge bases, which we're going to need. We're going to need to do an initialization. And the passes, you can do rules or you can do code or you can do functions, but we're going to do some code. I'm going to call it init, and I'm going to make a place in our brain called words. Okay, words here. And basically, this is the global variable words. I'm going to go to the root of our brain. I call it a brain, but it's a conceptual grammar. Just think of it as a database or a knowledge base. Get concept will create it if it's not there, and I'll make one for words. Hit Control-Shift-D, which I put in the editor because I hate not having a duplicate line. And we're going to call one order and put this one in order. We're going to make so this was going to make two nodes in the brain, two concepts in the brain called words in order. And now we're going to simply make a word pass. And I've already made this pass. So one of the things is if you make passes and delete them, they don't go away. If you come over to the output field, this is really nice. You can click on orphan passes. And I have these. And in fact, if you have them sitting there, it's a good way to even teach. You can go in here and say, I'm going to insert an orphan pass. So I'm going to sort words. And this is a real simple rule. Basically, it says look at anything alphanumeric, anything with an underscore X alpha. If you want to know what that is, just do look up word. It matches an alphanumeric token, so you can look that up. So basically, this is looking in the root at the top level, and it's going to match anything that's an alphabetic alphanumeric. I'm going to then get from node 1. In fact, I can say that explicitly if you want. You can say node 1. Get the text. This is a special thing. It says, this basically says get the text from node 1, make it lowercase, then add it to words. Get it means get it or create it. And then I make that word. So now we have a word under the words concept in our brain. We keep that in a local variable, and then we call this special function, which you can go to and see in our KB functions, which is increment count. And that basically will take that concept and increment a counter every time it gets it. So every time it comes to the word the, it's going to go find it or create it. If it's not there, creates it, gets it, then increments the count on that 1, 2. So every time it sees a word, it's going to be incrementing the count for that. Okay. And then the last thing we want to do is output this. Again, I'm just going to cheat here. I've already made it, do an orphan pass. So here's the output. And the output is just code again. And we have couple special variables. So when you're doing one text, when you're doing more than one text here, like in resumes, if I'm going to run this on this folder, we have special variables that says, is it a directory run? If it's directory, it says we don't want to output the brain. What happens with NLP++, as we're processing this text, if you process a folder, only one level, but a folder, it's going to accumulate the knowledge. You can literally it'll open up this text, go and find all the text, build it in the knowledge base, and that knowledge base for the words that we're building here in these words will keep accumulating. When it's adding it to this word, it'll add it to the word, go to the next file. And the next file, basically, it goes and gets a pointer to it. It doesn't destroy the brain. If I wanted to destroy it, I'd have to put something here. So this will remember, the brain, the conceptual grammar will remember things from file to file. So I say here, if this is the last file, if I'm processing a bunch of stuff, then I want to I'm going to call this special function that says order the words and put the ordering into a different part. So the words will be in, all the words we'll find are in words, and then it'll be ordered. So then we save all these words to a KB, which you're going to see come over here. So this is basically take all the words, order them by count, put them here, then save the words so we can see them visually in a KBB file, and then save the order in a KBB file to get our output. So that's the entire analyzer. So what we're going to do is we're going to run it on this. It's going to, what does it do? This is just functions, so it loads into functions. It comes to pass 3. It executes these, creates these things in the knowledge base. Then this one, it's going to go through the entire tree, every word. And if it's an alpha word, it's going to make a concept under word and then increment its count. So this will be called over the entire text. Then it goes to the next text, and it gets over the entire text. And when we're done, it says, oh, is this the last file? If it is, order it, order these and put the new order into a new place in the brain, save this so we can see it, save it so we can see it and see the output. So we're going to run that. And it says, do you want to turn off the log files? In NLP++, VisualText, we have log files so that we can see every tree at every step. Every step of the way, we can look at what's happening. We don't want to do that because we just want to run it. So I have a convenient thing that says if you have more than 10 files, turn off the logs. That makes it run faster. And do you want to analyze this folder? Be sure, because it will take longer. You see that? It's analyzing here. Doesn't take too long, and we're done. Now you notice over here we have some outputs. So let's take a look at the words. Here are all the words for all and accounts. So and is the most to data, and you can see that. Let's see them. The order of them. Oh, I got these wrong. I think. Oh my goodness. I think this one should be order, and this one should be words. Let's try and run that again. So yeah, I got it backwards because it's kind of confusing there. Let's see here. Words. Well, it's coming out. Let's see, this is what happened when you do this. I'm going to delete all these. Run it again. I'll put that back. Do. There we go. Let's run it again. Let's just leave it that like that. We don't want to waste time on that. You get the idea. It's still there. But see, that's what happens when you run these things. So here you'll have actually the words themselves. So you can see the words came in an order. And then you have counts for it. There's on, it's got a count of 13. That's what this was doing here. That's what this is, making a word in the hierarchy and putting a count on it. You notice this checkbox. Well, this does a kind of a bubble sort. And so I check off. If I go and find the biggest one, if I go do that, I actually go and write a check mark in it. And that's how I generate this, which is the order of them. So that's why you can see that. It's literally a bubble sort, and you can see how I did it. That's one of the great things about NLP++. It's visual. You can see what's going on, and you can do all kinds of sorts. So where's the bubble sort? It comes from this function that I just added this morning. Amnon says don't do that, but I did. It's called order by count. And this function will order by count. It basically takes concepts here and orders them here. And it uses a checkbox. So that's how it knows how to do it. Okay, but let's look at this and say, well, you know, I don't want to, notation is requesting annotate the shared content. Okay, not sure what that means. So anyways, what's interesting here is that we don't want to see necessarily function words. I don't want to see and the. So what do? Well, we have these kinds in a library, or even go to our English dictionary. Oops, that's not where we want to go. We want to go to stop words. So stop words are those words that are common words. So let's go here and go to stop words. So you can come over here in the knowledge base, click over here, come to stop words, choose English. There's Portuguese, Spanish, Chinese. We're going to click this, and here you have stop words. This is a dictionary file. We talked about this yesterday. If it sees this, it'll create a parent called stop and put that word under it. So here are all the kind of stop words. But the thing is if we run it, we're not going to see that. We're not going to see it there because this tokenized is not reading it. We need to read these things. So in other words, so when we look at this, we still get the stop words. For these things in the KB to function with our analyzer, we've got to change this to dictionary tokenizer. The dictionary is also KB, so it's going to read all this. So we're going to get rid of this because we don't want that as a part of our knowledge base, because we got to get rid of them because it's going to read this all in. So now what we wanted to do is that when it reads in a text, it's going to read in all the stop words, and the stop words are going to be pushed aside and called stop. And so let's run it again. Let's see what we get. We get the words, and all of a sudden you notice all the stop words are gone. Well, how did that happen? If you look at, oh, there was no final tree. I'll show you that. But the reason is we had those stop words and those were matched first. So here now I get in the resumes, I've got data, experience, SQL, Spring, project. Very interesting for me who are looking at resumes to know what kinds of words. So when I make my resume processing system that reads the entire resume, zones it, looks at everything in the resume and read it like a human. It's not keyword. We're going to make it. That's our idea. Then that happens. Let me just run one for you to see that you can see the tree. I'm going to turn the logs back on just so you can see this. We'll spend a little bit more time on this because we are actually. Oh, okay, that was weird. See, I'm going to run it again. See, the reason it took so long is it thought this was stuff it had to read into its brain. We don't need that. It should run much faster now. There it goes. And so if you look at this now, you notice when you come down here, you see stop and stop and. So when I go and I use this word and look at alpha, it's not going to find those anymore because those are set aside and now labeled as stop. And that's how that works. So this gives you an example of building an analyzer on the fly. In fact, this has inspired me to do a corpus study analyzer to have as one of the templates because it's going to be very common. You can look at words, word frequency, abbreviations, all those kinds of things. So this works, of course, in any language. So that's the corpus study. I'm going to go to another one now because we have resumes. And if you look at the resumes, one of the things that we don't understand until you start using NLP++ is that we humans, when we read this resume, the first thing we do isn't to read the name, then the email, and then this guy. We overlook it really quickly. And we look at the formatting to see what, oh, I see, here's a section up here, here's one here with list, here's one down here. And to teach people that, I've created this X out parser. And so basically you have all these resumes here. And the X out parser will break things into lines, and we're going to look at a test here. Here's any text, so it doesn't matter what text it is. It breaks things down into lines. Then it takes every word, gets the length of the word, loops through every letter, sets that letter to X lowercase. If the letter from the word is uppercase, it puts an uppercase, and then it makes the string. It then renames that word. That's what this is. Rename node 1 to be this new string. And what do you get? Well, let's run it. This happens to write it in the output. It writes it into a file here because when you do a lot of them, when you want to save it. So, yes.
Can you increase the font by one more?
One more. Okay, I will try because we're going to have very little space, but let me go ahead and do that because there's a lot to see here, but I can. All right, does that help? Okay.
Thank you.
Okay, I'm sorry about that. You're welcome. No problem. Okay, so in the output, we're actually putting it in these texts. So what happens is when you run any text, it puts it under what I call the X. That's what this output does. Not important. So let's take a look at why I'm doing this. Here's remember the text that we looked at. This is what it produces. All of a sudden, we realize we can write a parser to make these into paragraphs. We can see formatting much better. Let's take a look at a resume. You can see just by inspection, it could be in Chinese, it could be in Nepali, it could be in Portuguese. We can see where things are just by sort of here's, I'm sure, a header. There's another one. Here's some more information. So this is a good way for people and students of NLP++ to realize that you have to zone text. Human beings, when they read text that's formatted, they don't read just the words. We also read text. And this NLP++, you can write a parser that will find headers without ever knowing what those words are. This would be a secondary header. This is probably a first header. This is probably a name. I can see here's, of course, there's a phone number. I don't do it with the, and so you can see a whole lot without ever understanding any word. But the truth is, when you really do look at resumes, you will eventually have to start the words because not all of them are pretty. They're not all like this and well formatted. Some of them are really a mess. I wonder if I have here. Yeah, here we go. I mean, where's the header? You know, this is probably the end of a sentence, but you can see that this is to make everyone aware that we do a lot more with parsing than just looking at the words. I'm going to next do something that I did for NLP++, and that's NLP++ snippets. So what did I do? If you go to an NLP++ file like this, if you right click, if you're in Word, at least if you're, Windows, you can bring up this, the help here. In the help, if you go to NLP++, you go to predefined functions, you can then go to parse functions. This parse function, we only had information about their functions, their variables they call, the types in this kind of table. Well, how do I convert this? This is a pain. No, it's not. With NLP++, it's not. You come in here, copy it, and these are what? Parse functions. There they are. You copy it, and this is what you get. I need to make these into snippets. So if we run this, I parse it. This is the output. From this, I got this. This is the exact JSON that's in the snippet format for VS Code language extensions. I didn't have to write any of this. And where did it come from? It came from this. This is why every programmer on the planet, in my opinion, needs this. And we're not even doing NLP. We're just taking something that's a pain. We literally didn't have it anywhere else. We had it in HTML. And I said, this is the easiest way to do it. I did the same way with special functions, etc. You can look at the parsing. Again, if you want to know, these are the lines. You can then see the functions here. You can see the parentheses there. You can see the arguments there. And then you finally see the output. So the tree that I have, you can see, is a function. It's got its type, its description, function, arguments, type, description. So I've made the tree into something that I can then go and output by just looking at, go to a line, go to the root and path in the function, go under the function as you saw in the tree here. Go into the function, then look for function, description, etc. Function, type, and description, and then I can go grab all the stuff and just create the output. And that's what this is doing. When I have arguments, I loop through the arguments. Again, this is going to the tree here, looking at where I'm at. I match this because you can do this. You can see this is a really good thing you can do with NLP++. Unfold all. And you can see how I've organized it. There's the functions, there's the function, here's a function. So I've got them all down to that. So I'm matching underneath root function, I'm matching these three. That's what this is. I'm under root function, I'm matching this. And then when I match it, my post is to simply write into the file. This is just piping it into the file, all the things, and I get my output. Really interesting. Let me move on. The next one I want to take a look at are, we're going to move from that. We've got so much to see. Let's look at the states. This is a real fun one. I think everybody here is going to enjoy this one. A lot of people, of course, I don't think there's a young programmer today who doesn't know Python. Python to me is a scripting language. Real programmers use Python for scripting. Real programmers, I say, do like C++, JavaScript, TypeScript, PHP, all of these C++ like myself. So what I did is if you come over to the analyzers, you can create a README file so that when you put it up to GitHub, you'll have the README file. So the way you document anything you want in NLP++ analyzers is to create a README file. If you right click here, you can create or edit, you can open, you can delete or whatever. And then when you go up to put it into GitHub, I'll just teach a little side here. You can click on this, it'll delete all the log files, all those files that you have that are log files, and then you will then be able to upload that to GitHub, and those README files will stay around. So this is an interesting one where I went to, and I want to get information about states. So here are all these states, and every state you click on has all this information. Okay, now if you're to do an HTML parse and all that stuff, that's kind of a pain. So what I did is I got the URLs. That was pretty easy to get the URLs. Actually, I made another NLP++ analyzer to get that. Then I wrote a Python function. The Python function, you can see there's nothing in here. The Python function basically takes each URL, downloads it, and it'll put the result into this so that I can process it. So let's run this. If you click on this, because we're in NLP++, we want to go to just the running. So we'll run into debug, run this as a Python. You're going to then see down here, you're going to see it downloading all the web pages to NLP++ folder, and then we're going to process them. So. All right, so you're going to see that going, and I apologize. We get our lawn cut like once a month, and they come on the day where I'm doing this on the time. So, okay, there it is. It's all run. Now, if we go back to NLP++, we have all the states. Oh, I just got to refresh. There they are, Alaska. Now, this is in, of course, HTML. Now, you can go ahead and get an HTML parser and do all that, but when you really look at it, I took only about 10 minutes. I can find where things are. You can see that things are in a table. Here's the state flag. Here you can see everything. There's abbreviation. So what do? You start building a parser to do that. So we're going to do, let's just do Alabama, and we're going to parse that. I'm going to clean this out. I don't know, do I need to clean this out or not? Let's just run it. These abbreviations coming. Okay. All right, now those are going to go by the states. Okay, I'm going to clean it. Because some of the analyze, the reason you have this clean button in NLP++ is you want to, this analyzer is generating knowledge. So this clean is really nice because you can say, clean all the files below except for the knowledge base that I need. They're all gone. Let's run the analyzer. Okay, and you will see it generates these files. You notice that they are not active. This is something to understand. There's an active button. This is a .dict file. The reason I do that is if you run the parser now on this, it will not pull this in. It will not bring this in. So if you click on this, you'll see that it brings them active. It's just basically renaming it from TT at the end of BBB to BB, and we'll see what we've got. So we ran through all of these files. We got, we just ran through Alabama. We've got a dictionary with Alabama. It's the state. It's abbreviation. It just means true. It is abbreviation, and the state is Alabama. The cities in that web page are those. The states, if you want to do states, and we have information about the state. So we pulled all of this out of the web page. And how did I do it with NLP++? What makes it easier? Let's take a look at it. We'll step through it one part at a time. First, I do tags. That's pretty easy. Open, tag, collect everything until you get, that means collect on a wildcard. You fail when you get to this and then collect this. So it gets the T open because you have a lot of times you have attributes here. T close, it's just a pattern. You have a backslash in front of special characters. That's all that is. So when you do that, it matches all of them. And you can see where it matches. That's one of the nice things. That's what this symbol is. Shows you where it matches. This is what makes NLP++ so powerful, because anybody who hasn't seen this parser can click through these one at a time and see what's going on. Then we have a whole phrase. What's this one? It takes the T open, anything between it, It fails if it finds a T close or a T open, and then brings those together. So it's basically doing a TD to a TD. You notice here, right there, all of them. Yes, I have a lot of stuff I don't need. I don't care right now. I just want to get I'm building it bottom up. So here we go. The rest is everything but that. Why do I want to do that? Because I don't want to waste time processing on this. So what do you do for the rest? It just says rest. Anything that's not TD, make it the rest, then remove it. Next step says just get rid of it. I don't want to see it. Okay, so when I look at the tree now, what you see are only TDs. I can unfold, fold all. All you see is TDs. Now I'm getting closer. Now I want the text, the text tags here. So I look under the TD. One of the things about NLP++ is you can look underneath a node. So if you look at the tree, you got this underneath the node. We're looking at text tags. So what are the text tags? Well, when I have something like the state size inside this TD, right? This column. That's what this is. I've got this anchor. I don't want that. I just want this. Yes, if I had an HTML parser, I could go say get the text. But I don't want to do the HTML parser. I don't want to waste all my time on that. I can do this much faster. So what I do is I just say, okay, just make all the text tags underneath the TDs. Just go get all tags. Just get them all. And that's what you see here. You notice here's state capital. So all you see all these things in blue that have them. That's great. I then remove those. Okay. And now you see that all those tags are gone. All right. I do, let's see, what's this one? Tag text. I then go and I just get the text and put it there. Not important. We don't have time to do it all. I remove the white space. So now you see, look at that. It's all cleaned down to what I want. This is one of the great things. This is what I call about text zoning. Go and get the text you need in the fastest way you can get it. So this is really fast. You don't have to parse the HTML at all. This is really fast compared to a parser. So that's really good. And then we need to start labeling text. So what do? I go in here and I said underneath there, if I find state abbreviation, this will make it, change this to an abbreviation. So what I'm doing is I'm looking under each TD, finding this word state, because these are the only ones I'm going to interest in are these. If I wanted to, you could go in an exercise and change this and make more. But if in the TD, if you have the word state abbreviation, state capital, number of country, all of these, I then create, I relabel those. So let's take a look at what that does. So if you go down here, all of a sudden you see, oh, there's abbreviation where the TD was. That's what this does. We don't have time to talk about the code, but basically you're just finding the code inside there. If I sign state abbreviation, I'm going to call it state abbreviation. So state abbreviation, capital, number of counties, time zone, area codes, cities. Okay? And then I go and I start mashing in there. And the abbreviations, then I start doing stuff with abbreviations. I put them in the state. So when I'm building this knowledge base for Alabama, the states, let me put them over here. I'm building this. What this is doing, let me move this over. What this is doing is saying, how are you doing on time? Okay, I'm good. All right, so what I'm doing is underneath Alabama, I'm creating underneath for every file, Alabama, I'm creating a abbreviation. It's going and saying, go to state. Here's my state. I've got a global variable for the state I'm working in. Go to that, create a concept abbreviation if it's not there. Then I'm going to add a string value to it. I'm going to call that string letters, and I'm going to put the text for the abbreviation. There's the text. And then I said, you know, I'm going to make a dictionary file, the abbreviation dictionary file, and I'm going to put the text in it, string to lower. I'm going to say it's a suggested state, abbreviation 1 in the state, and quote if needed. Then put that, and that creates what? That creates the abbreviation dictionary file. So that creates this one. All right. Whoops. So yeah, so that's how I do that. And then I do that for area codes. I do the same thing, time zone. So I can do whatever I want. I'm creating all of these things with all of this stuff. And then finally, of course, I do a couple of things here. But again, I'm building, much more complicated. I'm building a knowledge base. I'm building this. So when we run it on the entire thing, let's run it on the entire, turn log files off. There are 50 of them. Yeah, I want to turn them off. Do you want to analyze them? Yep. So we're going to analyze them all. Oops, I forgot to clear it out. So, oh, that's funny. Yeah. Okay, so let's just look at this because we got to go on. And there we go, Alabama, Alaska, Arizona. We have all the states as well, again, because I didn't get rid of that. It's a minor thing, states. I made a dictionary for states. Oh, guess what? The dictionary for states, let's see here. Go to library dictionary, English dictionary, states. The thing you see here created this. It's now part of NLP++. It's part of VisualText. And that's what's powerful about this. We're going to talk about that at the end, how we all are going to be contributing to this. This is kind of like I call it global crowd programming. All right. The way we have it, I'm going to just go to the last one now. We do have many other ones we can look at. I can briefly look at some of these. Can look at the Department of Justice here, real quickly. Close all this. Close all this. And we'll get to the Department of Justice. Now, I made a video, which you can go to the YouTube channel, just search on VisualText, NLP++, you go to the YouTube channel. I have some, and also HPC Systems. No, that's in HPC Systems. You can go to our VisualText website and see those too. And I do talk about this, but it gives you an idea of what we can do. Now, I did a web crawler for the Department of Justice. We have this very complicated problem, whereas we need to find out who is being indicted for some crimes, and we say it's an indictment was against a St. Louis resident for his role. It's a male. They're from St. Louis. We have no name here. In the very first paragraph, we have no name. The second paragraph, we have Batunde Taiwo, and then we're told that it's him, and he's charged with these crimes. How do we process this? We're not going to do it by keywords. So I'm just going to run it. Oh, it is run, I guess. And we're going to take a look at the output here. Oh, whenever you don't see output, you got to remember they were turned off. Let's run it again. And what we have here is how I did this. First, I found all the names. Then I said, okay, some of these are people. And then I looked at here, we have accusing, we have events that happen. And I found out that in the first part, we had an event where we were accusing a person. That person had the sex of a female, a male. Let's see if we can switch on male. Okay. So we have here in sentence 3, we have he's male. And then in further on sentences, we have Babatunde. And so we have a way. How do we do that? Well, I keep track of what's in the sentences. I know that there is what we call an anaphora here. This is an anaphora. I then go and say, this is an anaphora. Where can I find who else? Where's the name who's being indicted? Because this is the person in the first sentence. His role, or his role, that is telling me it's a male. The upshot is I keep track of what's in the sentences. I keep track of what they are.
David, you're tracking it in the knowledge base, right?
Yeah, I'm tracking the knowledge base, right?
Yeah,
Thank you.
yeah.
Please. And there's so much to talk about. So yeah. So anyways, I track in the knowledge. I get all the names. I then figure out who are people by they have titles, or they live in a city. They say they are resident. If they're a resident, then I add. Here are names. It could be a name of anything. Even his. That's kind of a name. Taiwo. And then I find out, these names, which ones are people. I then look at the sentences to find his. His is going to refer to somebody indicted. Again, this is very complicated in some sense, but you can do it exactly as we humans do it. And we end up with this, that a person, Batunde Taiwo, is the category is an indictment. He's from the city of St. Louis, which is in a first sentence without his name, in the state of Missouri. Again, that's not in the same sentence. His gender is male, comes from his, and these are his crimes. This is just to show you the power of NLP++, what it can accomplish when you have a problem where you have information here and here all over the place, but you can't just do keywords. You're going to be in real trouble because there's a lot of different names there. Okay, I'm going to go to the last one, which is the, we're running out of time here, got 5 minutes. This is the full English parser. We're going to close all these things. And the full English parser is written by Amnon Meyers. The idea is without any, let me get rid of this stuff here.
David, this was not 20 years of work.
Oh, how many years of work was it?
Oh, I don't know. A few.
Okay. Well, it's been worked over during the last 20 years,
Yeah,
right?
yes,
That's
yes.
what I should say. When you are people who deal with language, we all make sure we say the correct thing. So yes, during the last 20 years, he has been improving it, making the pancakes work better. He's used it for one project, used it for another project, and each project he uses it on, he may have to improve it. And that's one of the great things about NLP++. Here's the dictionary that we use. English, it's just parts of speech. Each line is one part of speech. So if you have something that can be a noun and a verb, it's got a separate line. So there's 191,000 words with different parts of speech. And that is available to anyone right there. If I click on this, it will download that. There it is. And there's the same thing. Of course, we don't need that because we would have to read in both of them. And so what this does, it will take a text, and I hope I'm going to mute myself for a second. I can't believe they're doing this right when I'm doing this outside my window. Okay, hopefully you're hearing it. So what this is a parser, and we'll just do this one simple sentence. It will take any English you throw at it, anything, even words it has no idea, and it will try to make a syntactic parse tree out of it. It takes a little bit of time because it's got to read in this knowledge base. Then once it reads it in, then it'll run. So yes, it does take a lot longer because it has 136 passes. We can look at the final output here. Let's take a look at it. Now this final outlook here is show you that you have a noun phrase, a verb phrase, and an adverbial phrase, which is a preposition with a noun phrase. So over, the lazy boy. You have the quick brown fox. It does know things that are nouns and verbs. You can see, in fact, this one could be a noun, a verb, and an adjective. But the parser looks at everything and looking at the context around it, does its best guess as how to parse this. So we have an entire English parser available for everyone, and you can come along here and do highlights. Here you notice we have highlight passing, and that's what they do. You can see highlights. I don't know all of these are going to highlight. There's the whole phrase, but you can see there's the noun phrases, for instance. Parts of speech. There's parts of speech, probably looks it up. And again, the idea is you can look at the tree at that point. One of the things I like to do with this one, and this will be the end of this, but when it starts the tree, to start looking at the tree, and then look down further. You notice how each time it's building things. See that? This is why you can, without ever knowing what Amnon is doing, take a look. Oh, and what was the rule that did this? I go, and it goes and tells me the rule that gets this. And here's the rule. Yes, if you're not into linguistics and you don't know all these functions, yes, but you can see it. There's an adjective, there's a noun, there's a wildcard. So what it means is it could be any of these things. And this is the rule that fired this. So you can go and look at any of those rules. Here's the rule again. How do we know that? Is because inside we have all that information stored in here. That's what these numbers are. These are byte offsets. These are Unicode. These are byte offsets, display offsets, because sometimes Unicode and bytes are different. So if you're dealing with emojis or Chinese or something, and then you have the pass number and the line number. Yep, Amnon wrote an NLP++ file that has 10,000 lines. But again, the idea is it's all written, it's a glass box. If something in here doesn't work, you can go and change it. You can go in here and add stuff. You can pre-process stuff. You can go and make things that aren't working in this better. Maybe it's a date. Maybe it's like a name, comma, age. Whatever you want, you can come in here and then change it. So I am going to stop this, and we're going to go to our next part of the presentation, which is Amnon, and he is going to talk about real projects now that have been in the real world using this amazing technology. Okay, Amnon?
Yes. Why don't you go back one slide? Didn't I start a little? Are you one?
No.
No, that was you. Okay.
Yeah.
Never mind.
Yeah.
Okay, so David showed you, I guess, dynamic presentation of how the visual text interface works now, and I think some of that was at light speed, and given the fonts and so on, not everything was immediately apparent. So hopefully people can go back and look at the recording a few hundred times and see what David was doing in detail when that's of interest. Okay, so a lot of visual text analyzers were built during the tenure of Text Analysis International. We call it TAI. So TAI started at the end of 1998. It shut down after 20 years. But this is where visual text and NLP++ and conceptual grammar were all developed. And it was always a small company. Even with the initial funding round, there were never more than let's say about 7 or 8 people, including management, maybe never more than about 4 technology people involved. But even so, TAI had customers like IBM Global Services UK, Michael Page International, Educational Testing Service, which produces the SATs and GREs, the college entrance exams, NASDAQ, and a smaller company called New Vision Systems. So I'm showing here what application area each of these customers had. So IBM did their own analyzer using visual text for government meeting notes, things like that. Michael Page International dealt with job resumes for many European languages, especially. And Educational Testing Service did about a 5-year project on automatically generating test questions. And they use some kind of cascading sequence of visual text analyzers. I write how did they do that? I've never used visual text analyzers or NLP++ for language generation. I'd be interested to know how they did it. They never told me. Actually, one of our employees was named Paul Dean, went over to ETS, and I think he's now a high-level manager there. And he basically convinced them to use the NLP++ visual text technology to build these systems. And the bottom line here is all of these customers used our software because they compared it to others and decided that this was the best of breed. Someone like IBM Global Services has huge internal resources for natural language processing, but the Global Services is tasked with choosing the best thing out there, whether it's internal or external. So they chose us. I mean, that's a huge win for a tiny company to get that kind of recognition from these major companies. Next slide, please, David. So I can tell a little bit about the NASDAQ story. Basically, a company called Glide Technologies spent about a year evaluating every major NLP vendor, and they probably looked at about 100 companies. And they found VisualText and NLP++ late in the game, and they kind of grudgingly included us in their candidate suite. However, they found it was a lot better than they'd expected. The main person there, named Keith Woods Holder, found he could not break the technology. He couldn't find ways to make it not work. Basically, it always worked the way it should work. So VisualText and NLP++ were among 6 finalists chosen for building prototypes. And then VisualText was kind of the last system standing, and they chose us for their sentiment analysis application. Another reason they chose us is because we were a small company. The developers in that company would be able to devote all their attention to the problem and so on. So, it's not a pure technology thing, but that was a big part of the decision initially. NASDAQ acquired Glide and for the sentiment analysis solution, and so NASDAQ became our customer. Glide dissolved, and TAI maintained the sentiment analysis solution for several years for NASDAQ. And this was a huge, what do you call it, fire hose of information. They looked at all kinds of social media and so on, and visual text analyzers were deployed in a full production system for sentiment analysis for NASDAQ's commercial and government customers. Next slide. Okay, so there have been many analyzers built with visual text. I mean, too many to count, and I'm going to talk about some of the things that we've done over the years. One application domain was for processing real estate and clerk of court documents, things like mortgages, deeds, assignments, release of mortgage, and so on. Basically hundreds of types of documents and subtypes. So under deeds, there are all many different kinds of deeds, property deeds. And the OCRX analyzer basically took text that was OCR'd from images. Basically, the county clerks received images of deeds, images of mortgages, and so on. And basically, they received documents. They created the images, and part of the process the part of the process we were part of was to take OCR'd text, basically images that were reconverted to text, and analyze those. So this OCRX real estate analyzer was deployed in various county clerk offices, especially in New Jersey, by New Vision Systems. At about 266 passes, this OCRX analyzer is probably the most complex analyzer ever written with NLP++. Next slide. So again, the input consisted of hundreds of document types, and just like with resumes, everybody likes to have their own style. Every lawyer, every real estate firm has its own boilerplates, and some smaller companies just do everything by hand or from scratch with a lot of handwriting. So as I said, the clerks receive whatever documents, however they're written, and convert them to TIFF images. And even these original paper documents can be extremely dirty, and they come from many sources, as I say. So these images are converted with optical character recognition to some kind of text files. Typically, the OCR engines produce some kind of XML or HTML, and which includes pixel offsets, anything they can say about the organization, the formatting of the file, and so on. So the OCR conversion process can lead to a lot of garble and is called lossy. Basically, it loses a lot of information. And these original documents have signatures, they have random pencil markings by the clerks, they have document stamps, they can be at an angle, there can be vertical text. And the primary document types we're looking at for now are deeds and mortgages and their subtypes. The outputs, basically the clerk of court needs to have 100% accuracy in the information they pull out of these very messy documents. And so it's never a fully automated process. The text analyzer that we produced, the OCRX, was part of a workflow where human beings, people who work at the clerk of court, will have the input document in one pane of their computer screen and the output in another pane, and they can check and see what the system has done correctly, and the automated system can point them to regions of text to say, well, there was a date here, but it was handwritten, and it was too complex. I couldn't handle the date, but I know where it is, and I can highlight it for you. Things like that. Let's see. Yeah, and again, these documents have a lot of boilerplate. Like mortgages can be 60 pages long, and a lot of that is boilerplate language. So you have to find the parties, the dates, the amounts, the cost of the house, and so on. You have to find the non-boilerplate language and try to extract that. Next slide. So I said there are 266 passes. I don't know how much you can read of this, but this is what the actual passes of the OCRX analyzer look like. It's over 2 slides here. One thing you can notice is looking to the right, for example, it says Q day month year, Q day month, Q month year. So there are multiple passes just to try to get the date and the date of the deed transfer, the property transfer, and so on. So there are multiple passes associated with every single data item that's of interest. The names have a large number of passes. I think you'll see more of that on the next slide. I could spend a week talking about this analyzer. So yeah, you see Q name, there's a whole set of passes there. There's sets of passes for addresses and the pieces of addresses. And because these things are dirty and messy, you have to use context. You have to basically find where does the date or where does the address appear, and then you can work within those. And NLP++ is great for allowing you to work in very localized parts of the document and go back and revisit them based on other information you find across the document. For example, the name in a mortgage, the name of the parties to a mortgage may appear on page 1 and on page 64. Well, you want to be able to use those multiple instances of a name. One may be garbled, and 2 of them may be correct, and so you can use a good copy of a name to unify that with a garbled copy of a name, and so on. And of course, keeping names in the knowledge base, tracking things in the knowledge base, as David showed you, helps you build a model of what the entire text looks like, and to be able to do these kinds of fixes. Next slide. So even preparing the input, as I said, is a complicated process. You start with a paper document. The clerk of court on the left here would create a TIFF image for that. And on the left here, you can see what a typical document looks like once it's submitted to the county clerk. There's the date here. The quitclaim deed is made on the 18th of August, 2014. Well, there's the OCR that was used at the time would not be able to handle these handwritten fields. So again, the text analyzer can say, okay, I know where the date is supposed to appear, but I've got nothing out of it, and I can show you the pixel offsets where that date is supposed to be, and you, the human person at the terminal, can figure out by looking at the original image what that date was and just fill it in. And yeah, David, I don't know if these are the latest slides, but okay. So if you look at the barcode on the left image, and then you look at the one of the input formats on the right here, things like MIL, MIL, MG, NIL, HILL, all those things are actually barcode. Those are bars in the barcode. The input preparation is a bunch of steps. So the OCR will produce some kind of XML, and one of our collaborator companies produced something called CML that you see on the right, where each word or each blob in the text gets its own line, gets its confidence, gets its pixel offsets, and also it says what line number and what word number on the line each word of the document appears in. So it's takes the XML, converts this, it's called clicks markup language, the thing on the right, basically a compression of the XML language. Now the original clicks, the original CML didn't have these OCR section and column and paragraph. This is something I added very recently, because there was XML information that wasn't being passed to me, and I said, well, I need to enhance that and use the information, use more of the information that the OCR process gave. Let's move to the next slide. So in the OCRX analyzer, you're given this CML that you saw in the previous slide, but that's not a convenient way to view the input text of the document. So the OCRX analyzer has a specialized tokenization pass called CML tokenize that specifically takes this CML format as an input. It takes out all the pixel information and the line numbers and word numbers, and throws that onto a parse tree and only retains the text. Actually, it retains some of these tags that I added recently, and that CML tokenize should actually get rid of those as well as an option. The CML tokenize pass also creates a new copy of the input file that's only the plain text that you see here on the right. And it pretends that the input text to the whole NLP++ analyzer is this plain text file. So you never have to deal with the XML, you don't have to deal with the CML format and so on. You can actually highlight in plain text, just as though this were an ordinary plain text input file. And this is something I've told David that the new visual text interface could do as well. Like, anytime you transform something like HTML or XML and you get rid of all the tags, Well, you can create this retext file that becomes your new input file that you can do your highlighting and watch what the NLP++ passes are working on in a much more sensical, much more visual way, which is what we like to do. Okay, so the color highlighting on the right-hand side here is showing some of the critical information, the non-boilerplate information. So it's a quitclaim deed type. The parties involved are Barbara Senatori, Bruce Senatori. They're the grantors. Two of them are, she's the grantor. Two of them are the grantees. And the address of the property is listed here. The preparer is down at the bottom there. And you can see all these items highlighted. Basically, you can highlight anything you are interested in NLP++ passes that are devoted to highlighting. Next slide.
I believe you're done, Amnon.
Oh, really? Okay,
Yeah.
well, anyway, I could have, well, yeah, you don't have my latest version. I added a couple. I gave you a later one that had a couple more. Basically,
okay.
I had one slide about ship analyzer,
Okay.
Yeah.
We do have time, so let me just grab that probably.
Yeah, that's why I was a little confused.
Yeah.
You
so,
don't have the absolute latest, which I sent you.
Okay,
I think
we do. Okay. So let me get to that. Okay, there it is. Sorry about this, folks. We'll get right back here. Open.
Yeah, we could quickly go through the same slides again and see anything we missed.
Okay, yeah, here they are. You're right. I apologize for sure. We're going to go from the current slide. Here we go.
I'll start at the beginning of my part because I'll just incredibly quickly go through a little
Okay,
bit
but
more.
maybe we can start here. Share. How about this one?
Well,
we already did that.
Yeah, I mean, go up a little bit. Go up to the top of where I started. Just wanna. I think there was one slide missed up there. Yeah, so basically, I was going to talk about NLP analyzers, and there too many NLP++ analyzers have been built since the year 2000. Too many to count. I've got backups of everything somewhere, but just gathering all that historically and making a list, probably like 1,000 or more, or I don't even know how many. And there are various types of analyzers. The commercial deployments that I've talked about are just non-commercial tools for all kinds of things. For example, I do some Scrabble Club statistics, and I generate a beautiful colored XML file. Basically, I output HTML, I read it in as Excel, and create nice colored tables of Scrabble Club statistics, as an example. So we've built prototypes, demo analyzers. Some analyzers just build knowledge bases, as David has shown you. He's done a lot of integration of that kind of thing. Analyzers to convert things. So I talked about converting the CML or the XML from OCR, converting that to CML, converting the CML to plain text, and so on. There are any number of utilities. David talked about how he was processing web pages and had some various utilities to pull things out. And one of our programmers came in named Phil Shin, who's out there working in speech or whatever, and said anything thinkable, which is basically sort of a trademark of ours. You can build anything thinkable, you can implement anything thinkable with NLP++ and VisualText. Let's go down the slides. Yeah, so this one, yeah, go back to that one.
Well, we're kind of running out of time. Maybe we can
Okay.
just go
Okay,
to
just
this
okay,
one.
go
Where
to
we go?
yeah, this
Yeah.
one. So, another sample analyzer for a customer was to look through all kinds of historical literature like newspapers, and these were OCR'd as well by some companies, and just to pull out ship names and information related to ship names, which is much harder than it sounds because a ship name can be absolutely anything. Some ship names are just phrases like idioms and phrases. And okay,
And
so
how old were some of these documents?
I'm sorry, some of these are hundreds of years old. So it's spanning, I mean, from the Revolutionary War, I read a lot about Benedict Arnold fleeing on the Viper uh, before he was captured by the national forces, continental forces. Okay, so next up, various medical text analyzers have been built with visual text. Here's a chest radiology report analyzer, and you see it's using UMLS codes. It's extracting, basically, it's mapping to UMLS codes, a unified medical language system out there that's in popular use. Actually, currently, I have a customer. Um, I'm I'm processing pathology reports, and they're very happy with what they've seen with about a week's worth of work. He started using it on real text. Of course, I have sanitized text, and the customer is talking about moving on to other report types as well. So that's very exciting. And we're looking to automate medical coding altogether, which has been a very difficult thing for statistical NLP methods. There's really no good automated coding out there. I think that's about it, David.
Yes, I think it is. Let me go back to our slides to wrap up so we can get some questions. Um, okay, let's see from the current slide, share screen two. And all right, so where are we? I kind of broke it up into kind of three phases. We're in phase one. We're kind of getting out of that where you get what you put into it, meaning you almost always are building everything almost from scratch. You build it by hand. It doesn't mean that you can't do good work. It doesn't mean that it's not productive, because without visual text and everything, you're doing things that basically are almost deemed impossible. We're in kind of phase two, though, and that's where we're moving here, where we're starting to accumulate stuff and integrate. So we're building dictionaries. One group of students under Dr. Shoba is building an analyzer to read the Wiktionary pages for English, to extract and make a dictionary, a full English dictionary. We only use WordNet is used, and it's from 2004. Building knowledge bases, for instance, for medical domain is a big area, other domains. Also analyzers, what kinds of analyzers we can build. We have the analyzer for English. We should be able to build those for other languages as well. So the idea with the phase two and this new visual text 2 is that we are looking for people to build and integrate and share in the open source project. The integration is happening already. HPC system supercomputer. Text is big. Text can be real big. If anybody knows about Latin languages, Portuguese is specifically, they have 68 conjugations for every verb. So if you have tens of thousands of verbs, you're going to have over 1 million words. So if you want to have a dictionary of Portuguese so you can know every word and it's part of speech, its meaning, whatever, then having a supercomputer ability to integrate this in a supercomputer can be really helpful. For instance, if your analyzer in NLP++ takes 2 seconds, you may want to do 40 a second, then you're going to have to spin up 80 nodes on a supercomputer and run it that way. Integrating, it already integrates into C++. There is some older code that integrates into databases. Be able to call from Python. It is an NLP engine, is an NLP.exe. So NLP.exe can be called by any scripting language. And
David,
Yeah,
David, I mean, you know, one thing to note also is the older code still, you can compile knowledge bases, you can compile
right,
analyzers. You'll get
right,
about a 3 times speed increase, and
right.
so
We didn't
and
have
the
to auto
knowledge
compile.
bases will load instantaneously rather than
Right.
interpreted knowledge bases.
Right. So yeah, we have that availability. It's not in our VS Code visual text version right now, but that is you can do that. You can compile this and call it directly, and like Amnon says, you can load analyzers and knowledge bases, no matter what their size, pretty much instantaneously into memory. Then phase three is really it's like give a computer a big enough and organized conceptual grammar. That is, if we give and keep building this, and we give computers this big enough and organized conceptual grammar, we can develop an analyzer to read and learn on its own. We call an intelligent agent, I think. Is that what you called it, Amnon? So
Yeah,
that
well,
would
you
just
need some kind of reasoning engine on top of
right,
all this, of
exactly.
course.
You would
So.
exactly. But can you do it? Absolutely. Will we do it in our lifetimes? Possible. And finally, um, our conclusions is coding versus programming. Python is kind of coding. I know most of the people here are programmers. NLP++ and C++ are programming. So NLP++ is programming. It is not Python. It's not you call this from something. You have to program it just like you would C++ or any other language. A lot of people who learn coding are really just kind of learning how to do scripting. But I know the people listening to this are programmers. And I kind of came up with this morning, actually, crowd programming. There's no one person today can build a computer. There's not one person on the planet who understands everything and could do a computer from the software on up. We are now in the phase where we have technologies that it is impossible for one person to do. Well, no one person can build all the dictionaries, all the knowledge bases, all the analyzers needed. We have hundreds of human languages that are used every day. There are actually thousands. When I was studying linguistics, they said there were 1,400 languages in India. I'm sure some of that's gone down some, but the major languages, there's still hundreds of them. There's no one person can't do this. There's millions of pieces of knowledge. This is really a decade-long endeavor. We're in the beginning of it. People see that this has to be done. Computers don't learn this on their own because you can give it Chinese, a trillion texts of Chinese, and it can't ever figure out which of the characters is mother. We have to migrate that. And, this is a new computer language, NLP++. It's a new computer language, allows us to do something we could not do before.
Well,
NLP++.
David, maybe Rosetta Stones are, can be done automatically.
Well, yeah, but I'm saying,
you have English to Portuguese
well,
dictionaries, things like that could be used.
well, we've talked about that. Yeah, you have that, but still, it's knowledge. You have to know what word in Portuguese means mother, what word
Yeah,
in
at
Tamil
some
means
point,
mother.
yes.
Yeah,
Yes.
so we still have that, and the idea that machine learning neural networks will learn that, we know that's not going to happen. So NLP++ allows us to do intelligent programming. Visual text allows us to see text and knowledge, and that's really important because we, as humans, cannot keep a tree of all the text we read in a document, a real estate document in our heads. We can't do that. So visual text allows us to build these things and visualize these things. And of course, it will eventually allow us to do intelligent computing systems. So when you talk to a thing like Alexa, it will be able to converse with you because in NLP++, if you converse using an Alexa dialogue, can keep a knowledge base of what you said and be able to answer. Like my father's birthday is on August 21st, and if I ask him a day later, when is his birthday? Give me his age. If I already told him his age, they'll know what his is because they'll have a knowledge base of me and all the things that are important to me. Those kinds of things are not still being done. And this is a technology. And eventually, this idea that machine learning, for instance, or statistics will automatically have some magical thing that will make it sentient, well, it's not going to happen until we teach it certain knowledge. And so this will get us perhaps to that. So that's the end of our 2 days. And I'm sure if anybody has any questions, we can go ahead and answer them. We have 10 minutes left, I think.
Dear participants, if you have any questions, you can unmute yourself and ask, or you can post it in the chat.
I'll put some things in here. That's the website for it. You can go to the HPC system, VS code. Go ahead if you have a question. You can go to this to go to the actual plug, the extension for VS Code. People are dazed. It's late where you guys are.
You've snowed them, Dave.
Well, unfortunately, there was a lot to talk about. I probably talked too quickly, but
that's okay. You gave a flavor of it.
So one of the things I can say, and if anybody doesn't have any questions, or if you're still thinking of something, when you learn it, if you take the time to learn NLP++, you are going to, as a programmer, have something in your back pocket, not because you're going to do full processing of natural language, but you will have the ability to take text files that you've had, may want to have information, and you've looked at and say, I'm just not going to do it. What do we have instead of a pattern matching at all? We have regex. So I have found myself as a programmer, ECL programmer at times, C++, websites, all kinds of things that I use NLP++ for natural language processing endeavors with files at least 5 or 6 times a year. I use it, and without it, I know I have it in my back pocket. So whenever I come across something I may need, like for instance, we had documentation. The documentation was terrible, was in PDF format, but I could write an NLP++ parser to go ahead and make a lexer for making a lexer for an internal language we have in HPC systems. I made it for snippets, like you saw. So these are the kinds of things that if you take the time to learn it, which doesn't take too much time, it really is a language, the best language to deal with text in general. So.
Yeah, I do agree, David. Participants, if you do not have any question, I would like to thank David and Amnon for this wonderful workshop. Today's session, David showed us how, in a very simple way, how we can create an analyzer using a help page, and he also showed us about the resume analyzer and the state analyzer. And Amnon showed us the real-time applications of NLP++, the Glide and NASDAQ analyzer, OCRX case study, ShipX case study, and a medical text analysis. So this shows us that NLP++ is a really promising technology. One can look forward, and it's a simple technology to learn. And I thank all the participants for joining this session in this late evening. I've shared the feedback link in the chat. I request all the participants to share your feedback. It's really very important to us. And last thing, I would like to share my screen. So here we at RVCE HPC Systems Center for Excellence in Cognitive Intelligence Systems for Sustainable Solution, Center of Excellence. We are organizing a 1 week or a 5 days proficiency course on big data analytics using high performance computing cluster systems during March 27 to 31st. And it's going to be in a blended mode. Wherein you can either wish to attend it online or offline sessions. We have both theory and practical sessions. So morning sessions are usually devoted for the theory, and the afternoon sessions are for the lab sessions. So you can see here 27th, we have introduction to distributed platforms, Hadoop and HPC systems, and introduction to ECL programming. In the afternoon, we are going to cover installation of HPC systems. On the second day, we are going to start with the basics of ECL programming language, and in the afternoon, hands-on on.
Oh, we've lost her. Maybe we can turn us off. Amnon.
Yeah.
Maybe that'll help the
Sure.
feed there. So yes, if people can hear me, I guess Somesh is talking about this 5-day workshop, which is part of the, I guess, HPCC and RVCE relationship. And it's coming up, I guess it looks like in March, right? 27th, 28th, 29th, 30th March. It looks like it includes also the NLP++. I see that seemed to be there on the 30th. And so they'll be talking about all of those different topics. And the other thing is too, those who are watching, you can also contact myself or Amnon if you have any questions or difficulties with the NLP++ part. It is callable by ECL, by the supercomputer. So if you have lots, millions of pieces of text, you can call that directly in ECL as well from the supercomputer. That's also, and you can also use it standalone. ACL NLP engine is an executable that runs on all 3 platforms. So, but this looks really interesting. I know I'm an ECL programmer. If anybody who's learned Hadoop, you learn ECL, you're not going to want to go back, because the ECL programming language is really an amazing way to deal with. You don't have to worry too much about the actual supercomputing part. You can just concentrate on what you're wanting to do. So I don't know. Do you still hear me, Amnon?
Yeah, you are audible, sir.
Yes, I hear you.
And so is Somesh, are you there?
She's not online.
Okay.
Yeah,
Okay.
they
Does
fell off.
somebody else have control of these slides?
Yeah,
Some
yeah,
of the hosts. Can you maybe, do you know about this and talk about it? If not, I can talk about it. Can someone scroll down a little bit on that?
No, that option she shared. We don't have
Okay.
that.
Okay. Okay. Do you know anything more about this happening in March?
Yeah, that is March 27, sir. 27 to 30th. 5 days workshop on this big data using HPCC, that is high performance computing workshop. So those who are willing to register, you can register. Participants, we have already sent a link. You can register through the link. We will share shortly. Then you can register for the workshop. I think if you want to know about ECL programming language and NLP++ also, it is there. So we got good insight from both of you, sir. Very nice presentation about NLP++, that is that language, programming language. So we will try to incorporate all those things.
Yeah, we'll be very willing to help you out with those kinds of presentations as well. And like I said, we are available. Take advantage of us now, because this is kind of growing pretty quickly. And you can have direct contact with myself and Amnon. We're the architects of the system, and we'd be more than happy. I can help you specifically with anything with the VS Code NLP++ extension. So if you're having a problem running it, or if it's not working, sometimes I do quite a lot of updates on both the engine and on the NLP++ visual extension. Also, you can do ECL, the ECL language, in the HPC systems, also using the ECL language extension, and that is also available. A lot of people are using that exclusively. So you can do all of these things through the VS Code editor, which has become very popular. So I can mention that as well.
Yeah, thank you, sir. Thank you very much. Wonderful presentation. So we are also doing project in dictionary and other things. Our students are already involved. Dictionary things and analyzer, text analyzer. They are very much interested towards ECL also. ECL language they are already learning. They have already learned some students. Now some new students they are now involving in so many projects with HPCC. So they are very much interested to know all the new technologies, techniques, whatever is coming, whatever presentation you are giving from your side, that is real time, then R&D work. So they're very much interested. We are also looking forward so that latest recent updates from your side, your end, sir.
Right. And also there is the machine learning components for HPC systems as well. So for those things that you're looking over, look at statistical or things, patterns of things in a large amount of data. You have all the machine learning with Roger Dev. And then, of course, now you have the NLP++ plugin where you can do more knowledge-based linguistic kind of processing, which is now a thing that people are looking at. Also interesting that we do have internships at HPC Systems. One of them looks like it's going to be happening is an Indian student here in the United States. Looks like we're going to pretty close to approving doing the Tamil dictionary from Wiktionary. The idea would be to produce a dictionary of Tamil with the parts of speech that then could be grown into making analyzers. So we're kind of in a building process, and one of the great things with working with RVCE is that we have this long-term relationship over the many years, and we can really build some really amazing technology together. Students can learn about it. They can learn about the HPC systems, its machine learning packages, as well as now the NLP, more traditional knowledge-based NLP package. That's been very fruitful. So you want to also check out, I think this year's internships are pretty much almost taken, but next year, if you are a student and are interested, we have people working on these technology HPC systems. So, okay.
Yes, sir. Regarding internship also, we received mails, and our students also, they submitted chat GPT, that internship. And one more thing, it got selected also, one internship from your side. We got mail also. So two more also we have already submitted, sir. We are expecting
Yes.
result from your end. So students also, they are very much interested. Thank you, sir. Thank you.
Yes. They seem to be very interested. They're very good. I'll tell you, the students I've worked with at the university, RVCE, are just excellent. It's not an easy thing, this paradigm shift, and I think they really grasp it in a very short amount of time. ECL is the same way. It's very different. You have to have kind of, learn, sit back. It's not a typical language, but your students seem to be picking up very fast. A lot of bright kids, a lot of bright future for the software industry. So thank you once again for your cooperation with LexisNexis. It's been very fruitful.
Yes, sir. Thank you. Thank you very much. Thank you, sir. Shall I wind up?
Yes,
meeting?
I think so. Yeah.
Yeah, thank you, sir. Thank you very much. Participants, you can, we have already shared the link, feedback link. You can fill the feedback link.
So
Thank
there
you.
will be a recording.
Yes, sir, it is there. Recording is there.
Okay, so you will have the availability of this recording afterwards so people can see it?
Yeah, yes, yes, yes.
Okay. All righty. Thank you so much.
Thank you, sir. Thank you. Bye.
Bye.